In this tutorial, we're going to talk about significant figures, which sounds so exciting, I know, and it is. So what the heck is a sig fig? A sig fig is a digit or the digits in a measured number that you know to a reliable degree. Hopefully you have watched the video on measurements and you know how to make an appropriate measurement, because when I say that you know these digits to a reliable degree, what I really mean by that is that they are the certain digits and the one estimated digit in a measurement. So let's do an example of what I mean by that. So here's a thermometer, and we're going to assume a couple of things about this thermometer. So first of all, we're going to assume that this is in degrees Celsius, because it doesn't say that it's in degrees Celsius, so we need to make sure that we indicate the unit that's going to go on our measurement. And we're going to make this measurement of temperature. So we know that our certain digits are the digits that the thermometer reading goes past. So it goes past 80, 1, 2, 3, 4, 5, 6, 7. So we know that our certain digits are 87, and then that thermometer reading is about halfway between the 87 and the 88, and so we're going to estimate a final digit. So I would say that looks about 87.5. You may say it's 87.6 or 87.4, whichever, it doesn't matter. And then, of course, it's a degree Celsius is our unit. So there's our measurement. The digits that we put in this measurement are all significant. So there are 1, 2, 3 sig figs, 3 sig figs in this measurement. So all the digits that we are certain of and our one estimated digit are our sig figs. Well, what if you didn't make the measurement? What if the measurement was just given to you? So for example, let's say I gave you this measurement. I said, you have, or I used 0.002050 liters in some experiment, and I wanted you to tell me how many sig figs are in that measurement. Well, you didn't make it, so how are you going to know? Well, lucky for you, there are rules for how to count sig figs in a measured number. All right, so we'll come back to this example when I'm done giving you the rules. For now, let's go through the rules. So there are 5 rules. Okay, rule number 1 is that all non-zero digits in a measurement are significant. So, for example, if I gave you this measurement right here, you have 236. Okay, all of those are non-zero digits, so this has 3 sig figs. Okay, so this leaves us with the zeros. When are zeros significant and when are they just placeholders? Well, zeros that are in between non-zero digits are considered significant because they're not placeholders. You can't have a placeholder in the middle of a number. So for example, if I have a number like 405, say, grams, we know the 4 and the 5 are significant because of rule 1, but then the 0 is also significant because it's in between non-zero digits. So this would have 3 sig figs. This number, this measurement, has 3 significant figures. What if there's a lot of zeros in between, like this? So we have 400,005 grams. So those are significant because they're not zeros, and then all of these are also significant because they're in between non-zero digits. They're bookended by non-zero digits. So that means this has 1, 2, 3, 4, 5, 6 sig figs. So what other kind of zeros could you have in a number? Well, sometimes you have zeros at the beginning of a number. So for example, you might have a measurement like this, 0.00005. Maybe that's milliliters or something like that. These are considered zeros at the beginning of a number. They are never significant, never, never, never. They're placeholders. So PH means placeholders, right? In this case, they're placeholders, they're not significant. So the only digit in this number that would be considered a significant digit is this 5. So this number has 1 sig fig. And a little rule that I like to use is I put the number in scientific notation. So if I make that scientific notation, if I move the decimal to here and put it into scientific notation, or sorry, move it to here, then I get 5 times 10 to the negative 4. And notice that all those zeros dropped off, which means they were just placeholders. So I only have 1 sig fig. What about zeros at the end of a number? So, for example, let's say I have a number like this, 100. Are those zeros significant or not? They're only significant if there's a decimal in the number somewhere, which means that as far as I'm concerned in this number, 1 is my only significant figure, and those zeros, again, are placeholders, right? So these are placeholders. And again, if I wanted to, I could put this number into scientific notation, and I would end up getting 1 times 10 to the second, and those zeros fall off, and I end up with only 1 sig fig in my number. I'm going to move this up just a little bit. Well, what if I wanted those zeros to be significant? How would they be? How could I make them significant? Well, what if I made the number like this? So now there's a decimal in that number, which means that because there's a decimal in the number, those zeros at the end are significant. So that means I've got 1, 2, 3, 4 sig figs in this digit, or in this number. Hopefully you realize that this number and this number have varying levels of accuracy or precision because whatever made those measurements measured to different decimal places. If you don't understand that, that's fine. I just need you to understand the rule that zeros at the end of a number are significant only if there is a decimal in the number. So let's go back to that original number that I gave you right here. This original number right here. Let's talk about what digits in that number are significant. All right, so let's look at our rules. So let's just kind of systematically figure this out. So we know that according to Rule 1, all non-zero digits are significant. So I'm just going to go ahead and underline the non-zero digits. So far we know the 2 and the 5 are definitely significant in this particular measurement. The second rule says that in between non-zero digits, or zeros in between non-zero digits, are also significant. So that makes this 0 significant because it's between 2 non-zero digits. Rule number 3, which is right here, says that zeros at the beginning of a number are never significant. So that means that this 0, and this 0 are just placeholders. They're not considered significant digits. And if I were to put that number into scientific notation, those 3 zeros would fall away, which means they're just placeholders. And then the last rule says that zeros at the end are significant only if there's a decimal in the number. And hopefully you remember, and I'll make sure it's very clear, there is a decimal right there. And so that makes this 0 a significant 0, or a significant digit, because it comes after a decimal somewhere in the number. So that gives 4 sig figs for this particular measurement. All right, there's one last rule for sig figs that we need to discuss, and that is about exact numbers. I'm going to go ahead and move this up so we can talk just about exact numbers. So what do I mean when I say an exact number? An exact number is a counted number. They're usually integers, and they're literally, you have counted a number of items. So here I have 7 pennies. So I could write down that I have 7 pennies. Now here's the thing. I didn't measure the number of pennies. Oh, sorry. I don't know what I was doing there. I have 7 pennies. There are exactly 7 pennies. I didn't estimate this. I didn't just eyeball it. I counted 1, 2, 3, 4, 5, 6, 7. This is an exact number. And what that really means is there's no estimated digit in my measurement. There are 7.0000000 all the way to infinity pennies. So this is an exact number, which means that we have an infinite number of sig figs. Something you need to know about exact numbers, conversion factors are exact numbers. for example, if I say there are 12 donuts in a dozen, that 12 and that 1 are exact numbers. There are exactly 12 donuts in exactly 1 dozen. You may be asking yourself this question: why do we care about sig figs? Why does it matter? Well, have you ever been making a calculation in your calculator and it gives you a whole bunch of decimal places and you've been wondering exactly where you're supposed to round that answer? Well, if you know your sig fig rules, then you'll know where to round your answer, and that's why it matters. All right, so let's, for example, say you had measured the volume of an object and the mass of that object, and you now want to calculate the density. And density is mass divided by volume. And just a little trick to remember that density is mass divided by volume. I like to draw a heart and draw a line through it, and the top becomes an M and the bottom becomes a V, just FYI. So if I do that and I plug the numbers in, so I get mass is 35 grams, and I'm dividing by 12.2 milliliters. And I put that into my calculator. What I end up getting, this is what my calculator spits out: 2.868852459. Oh, sorry, that decimal doesn't go on the end there. Okay, so that's the number that my calculator gives me. I don't want to have to write that whole thing down. I want to know exactly where I'm supposed to round. Well, my answer can't be any more precise than my least precise measurement. So let's go back and look at our measurements up here. So we've got this measurement, which has 3 sig figs, and we have this measurement, which only has 2 sig figs. And we divided one by the other, so that's division. And since this 35 is less precise than 12.2, that means that I can only report my answer to 2 sig figs, because 2 sig figs is less precise than these 3 sig figs. So I would want to round to 2 sig figs, which means that I want to round this number to be 2.89. Now, if rounding is something that you have an issue with, you're going to need to come and talk to me about how to round a number, because I'm not going to go through how to round numbers at this point. I feel like you should know that. And by the way, the units on this are grams per milliliter, right there. So that's what you would want to write down with the correct number of sig figs in your answer. So just so you know, the rules for reporting a calculated number in the correct number of sig figs is different for adding and subtracting. So let's go through both rules. So depending on the operation, you are going to round to a different number of sig figs. So there are basically 2 types of operations we're going to talk about. Multiplying and dividing, and then adding and subtracting. So for multiplying and dividing, your rule is that you're going to round your answer to have the same number of sig figs as the component with the least sig figs. So let me give you an example. If I multiply 2.01 by 1.5, my calculator gives me this number. And when you're doing sig figs, you always want to actually do it in your calculator, and then don't write that number down. What you want to do is round it in your head and then write it down. But this is what your calculator gives you. Now, if you look at the 2 numbers associated with this calculation, you've got this, which has 3 sig figs, and this only has 2 sig figs. So again, you want your answer to have only the least amount that your components did. That means you want to round so that you only have 2 sig figs. So you're going to round this number to 3.0. So there's your final answer. You don't write that down, you write this down. Now the rule for adding and subtracting is slightly different. In this case, you're going to look at decimal places. So example. Let's say we have 28.602 and we're adding it to 2.1, and then we're adding that to 0.006. So what we're going to look at is decimal places in this case, and I'm going to rewrite this so that they're stacked on top of each other, because I think it'll help you visualize a little bit better how these line up. So you want to go ahead, like I said, with multiplication and division rule above, you want to go ahead and actually do the math in your calculator. I'm going to go ahead and write down the answer that you get in your calculator. You get 30.7026. But I don't want to actually write down all those digits in the end and report my answer that way. Because if you look at this, you'll notice that if you look at the degree of precision, this right here goes the least number of decimal places. So you want to make sure that you round so that your answer only goes as precise as the least precise measurement. In this case, it's the 2.1 because it only goes out one decimal place. So you're actually going to round to that 7 or to the 10th place, and so you'll report your answer as 30.7. So in this case, you were looking at decimal places, whereas in multiplication and division, you are looking at actual number of sig figs.